Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. In our last lecture, we have discussed about spatial method in planning research. There we discussed about several applications and also we discussed the different techniques which are very basic like overlay, buffer, terrain analysis, network analysis, etc. Hope that discussion was fruitful and you got certain insight and things are clear. Today, I'll be discussing a case study where we have applied that particular approach, the spatial analysis. So, in this particular case, we have used both qualitative and quantitative research method, and we just use this mixed method to have a desired outcome, right. So, without any further delay, let us focus on this particular lecture number 54, which is spatial methods in planning research case study. In this particular lecture, we will discuss one case study and we summarize our understanding. So, here is the paper. The title of the paper is GIS-MCDM based approach to determine the potential facility locations for park and ride facilities along transit corridors. Now, here if you see that GIS-MCDM based, so in this case again we have applied a mixed method, but I have explained this particular thing in our mixed method lecture, that depending on the research questions and need, we may require both qualitative and quantitative approaches. So, in this case GIS application is the spatial method where we quantify some of the things, and then in MCDM again we have done some sort of expert based opinion survey which is qualitative in nature. So, it is a blend of qualitative and quantitative research. The paper is authored by Aditya Manish Petle, Dr. Manoranjan Parida and myself. This paper was published in Journal of Urban Planning and Development. It is a journal from American Society of Civil Engineers. I have also given the DOI and the QR code to get access to this particular paper. Now, talking about the background, already we have discussed some of the other case study on park and ride. So, I am not going to detail it out, but if someone missed it out the previous lectures. So, park and ride is a facility where from your home you use your own vehicle. It may be two-wheeler, it may be cycle, it may be car. So, it is your personalized vehicle. You go to nearest transit station or public transport station and there you park your vehicle, and then you use that particular public transport for remaining of your journey. You get down to another station and then you reach to your destination by some sort of egress means. It may be just walking if it is nearby or some other modes available there. So, what is the advantage? Definitely the moment you just transfer your trip from private vehicle to public transport. So, automatically because of the group transport, effectively you can able to reduce the vehicle kilometer travel. So, park and ride shorten trip length of private vehicles and reduces the vehicle kilometer travel by ensuring the maximum length of the trip is covered by public transport. So, if the total distance is say 100, maybe 10 or 15 you use your own vehicle, the private transport, and remaining 90 to 85 that you cover with the public transport. So, automatically if you are doing it like that, there are other people they are also doing it, effectively we are saving some sort of energy, fuel, and also it can indirectly and directly saving some of the other aspect. So it can also help in reducing the pollution, because otherwise when you just use it with the conventional fuel, so automatically it can lead to some pollution and congestion. The integration between park and ride location and transit station is very essential for a seamless journey experience. Next thing is that where this park and ride, like where you can park your vehicle and ride your public transport, so where that location should be. So this location determination is very important. If that particular location is not having those kind of demand, so it will be underutilized. And if it is planned like with a small size but having high demand, so then there will be some sort of miss opportunity. Now selection of an optimal location for park and ride serves for an area to provide the economic benefit to the user and the operator and long term positive impact. So that is very important, that is the background. And then we also identified in this research the gap, that several criteria define how a location can be optimal for park and ride. It is not a single criteria, only the distance or maybe only the cost. There are other few criteria also play crucial role. So that is why it is coming under MCDM, so multi criteria decision making. So this part of the research is actually the MCDM. No approach exists that can simultaneously consider this criteria to determine the appropriate weight and delineate the location on the ground. So whenever we want to delineate this on the ground, we need certain kind of spatial references. So GIS comes into picture. So there is a need to develop an approach that can calculate weight of criteria and also spatially identify the appropriate location. So we just go for this MEX method, where we consider the criteria weight, which is derived from the expert opinion, and then also with the score based approach to identify the potential location for park and ride. That was the overall task. Coming to the objective of the study, it is to identify the Delhi Metro Rail Corporation DMRC transit station that have the potential to provide park and ride. So where to be located? So it also depend on certain demand and the location. So as because the DMRC or the Delhi Metro is one of that successful metro operation in the country, India, so we thought of doing this investigation based on Delhi. So here you can see a map and you can identify that how well connected it is with various metro lines. So you have blue lines, yellow lines, which is one of the oldest line in that particular network. You have certain express line which connect important transport station, railway station to airport, etc. We have red line, we have green line, violet line, pink line, magenta line, and things are also evolving. Along with that also the road network. So it has a good coverage, and then the overall boundary that you can see, that is about the Delhi traffic analysis zone. Now coming to the methodology, how we have done this analysis. Based on thorough literature, we have seen certain criteria, then based on certain factor frequency analysis, we have shortlisted certain set of criteria which we further use in designing the questionnaire and conduct the expert opinion survey to get the weight. Now once we identify the criteria, then what we have done in twofold. So in one side we are actually interested to understand the weight, and for that what we have done, we developed a questionnaire where performing pairwise comparison survey was actually the approach. So where pairwise comparison matrices were given to different experts, and we have used the AHP in our analytic hierarchy process. So, where two criteria simultaneously is compared, like that if we have say number of criteria, so always it is compared with each other, and then finally the relative score is given. Say for example, if you have criteria A and B, and A is higher than B to that person, or to me probably A is much more important than B, then I give a higher score to A compared to B. Then similarly, if we consider B is greater than C and I give certain score here, so then it is referred B as C. Now in this particular comparison, so there are certain check, that is one add-on to this particular method of HP, that is about the CR value, which is consistency ratio, that it will ensure the logical input. Say for example, if A is greater than B and B is greater than C, so automatically it should be A is greater than C. So if the respondent is going to give the opposite, like C is greater than A, so that means there is a logical error. And for such kind of case, through those eigenvalue and all, today I am not going to discuss the HP in detail. So we just calculate the individual priorities and the consistency ratio, and then a threshold value is 10% or 0.1 for the value. So if the consistency ratio of the responses of the expert is less than equal to 10%, we accept that particular result. If not, again in such cases we have to go back to the expert and just try to identify the conflict point or the logical sequencing of those responses, and then you can rectify. In this particular case, definitely when you approach to one expert, one may give certain sort of responses, the other may give certain responses, and for that what we have done in this particular case, first we have actually reject all those responses where the consistency was the issue. Where it is all okay, then we aggregate the finding using a geometric mean, because it is mentioned in literature that for aggregating the expert opinion, geometric mean is preferred to arithmetic mean. Now from there we finally get the criteria weight. So if you have criteria 1, criteria 2, criteria 3, so now we get certain sort of relative weight, okay, x1, x2 and x3, where the total weight, if we just sum, that is 1. Now this is one part where we involve the expert and then we conducted something which is again a qualitative research. On other side, based on this criteria, we have also decided some kind of criteria labels, and then we have done some classification and assignment of score for those labels if that is present, which is having some sort of spatial value, and those kind of labels are also checked through literature and also discussion with the expert that whether it is justified. And after that we develop the different criteria maps, and finally we overlap all the maps to get those potential location. So here we are actually mixing these two, the criteria weight from HP, expert weight survey, which is qualitative in nature, and then from this score it is having the quantification, and then we mix. So this is again a mixed method research, but as because it has the spatial application, so I put this particular case study in this particular head of spatial analysis. Now coming to the type of data, so here we have developed ranges for each score under each criteria based on the labels. Weight of each criteria we actually derived from the expert opinion, which actually help to determine the potential location. Then information of all transit station for each considered criteria were taken into consideration. Now, in this particular case, we have finally selected 7 criteria based on thorough literature review, based on initial discussion with the expert, and also the contextual evidence. So, the criteria 1 is the distance from the major activity center or CBD. Then criteria number 2 is distance from the transit station. If that particular distance is too much, so definitely people will not really be attracted to that particular station. Distance from major road, location before traffic congestion, because whenever people get the congestion, probably they will not be happy to go ahead. Surrounding land use can play a crucial role. Service to maximum population and distance from other PNR, because that is something creating a competition, and where like if you have too many parking lot in nearby area, so definitely then utilization of those will not be uniform, and then obviously there will be underutilization. So for that different labels were set. Say for example, we have assigned a score the distance from major activity center CBD. If the distance is less than 6.4 kilometer, we give only 1 score. If it is more than 16, so then we are giving the maximum score. Now, why it is so? That because whenever it is something like close to a CBD area, rather than using that parking lot for the PNR, people can also park for shopping activity or other activity. That is why it is something where we expect more distance from that. But when you consider the distance from the transit station, that your home location to transit, so definitely whenever it is less than 150 meter, so then this particular case, like where your park and ride facility and the station, they are within 150 meter nearby, like you just park your vehicle and in few meters you are getting the station. So that is getting the maximum value. Similarly, for other distance from major road, we also have the similar classification and value, and then we also take the service to maximum population, where less than 10,000 person or more than you can say 50,000 person per square kilometer. So we are taking the density as a measurement and we give certain sort of score. Now, type of survey in this particular case, for those kind of score and other thing, that we use the GIS and we measure all the distance and then we assign the score. But for criteria, we have designed the pairwise comparison expert opinion survey for determining weights of all 7 criteria that I have just mentioned. Questionnaire with 21 pairwise comparison that was actually constructed to calculate. So this is something a sample questions where position close to the trip origin and locating nearer to the transit station, between these two aspects, how much more important it is. So say for example, if I say that locating nearer to the transit station is much more important than the position close to the trip origin, so I give a score here. So that means this is preferred, or this is much more important than this. Similarly, for all 21 pairwise comparison, the expert they have answered. 15 experts were selected for assigning the weight, and finally we have used the geometric mean to aggregate the result, and we check the consistency ratio, and wherever there were issues, we again get back to the expert and then clarify that. Along with that, we also gathered other secondary data, which are like land use data, the major route data, etc. And also in this particular case, the land use and study area boundary that we have taken from the draft master plan of Delhi, Major roads we have taken from selected corridor map. Then we have certain sort of metro network and location from the influence zone of DMRC. Those are very important because this is going to help us to identify the spatial features and all those characteristics. Now, type of method in this case, as already I have mentioned, that it is a spatial MCDM approach where we used GIS and also the criteria weight by AHP. Scoring location through identified spatial criteria, and then also we have used the criteria maps. So, in this case, so scoring was done based on spatial distance and all the values with the population and all. We have used the analytic hierarchy process to determine the criteria weight, and in this case calculating the weighted score was crucial. So, we have one score for each criteria and then we have weight. So, finally, it is the weighted score and which is actually giving you the set of information. Now, for each criteria there are certain sort of weighted score. Finally, we aggregate all of them and then the top scorer, the weighted scorer, we identify at top 10 potential location. Now, the rationale for the method, the overlays of quantitative values on spatial map was actually the purpose, and that we have followed here, which actually help to practically identify the constant location and potential location. The mix of this qualitative and quantitative technique was used to solve the empirical issues, because only just having some numerical data about certain score will not help. When we can see spatially, so then definitely it is very much helpful to take a decision. Now, coming to the findings. So, here what we have observed, that based on that HP analysis where we have used the expert survey, service to maximum population is actually highly influence the location of PNR. So, this is perceived as the most important criteria, followed by the distance from transit station. The least important is given by expert to the distance from PNR from major activity to CBD, which we consider that okay, it should be away from that particular CBD. Now, coming to this particular thematic map individually, when you consider about the first criteria, distance from activity center. So, here you can see that the area which is in lighter color. So, this is basically your CBD area, the core of the Delhi, and then different color that has been used for different levels. So, up to 6.4 kilometer, then we have very limited zone where you have this 6.4 to 8, 8 to 16 and more than 16, which is the periphery where the network has not reached. Now, coming to the distance from transit station. So, in this case all these particular station that are located here, we have this more than 450 meter, 300 meter to 450 meter. So, these are plotted here. Now, this is about the distance from major road. So, here also we have used certain buffer. So, all the major roads were used as the network, and then we have used certain buffer analysis in GIS, and in this case we have used the ArcGIS, where we have again making those kind of thematic map, where less than 200 meter you can see it is very densified just along with that blue line, and then we have subsequently having those areas where we have less connectivity. Next one was the location before recurring the traffic congestion. So, in this case also we have seen certain sort of area where those kind of locations are determined. Now, coming to the surrounding land use. So, here if you see that the periphery, why it was also not covered. So, those areas are much more like a vacant area or agriculture area. And also if you see that some of the areas in this particular case is recreational, commercial, industrial area that you can get it here. So this is another thematic map that is prepared based on the score that we obtained. Now service to maximum population, where we have gathered the information from census data about the population density of those kind of zones, and where we have seen that the locations where there are certain sort of commercial area and other thing, those are like, you can say, the trip attraction zone. But you have certain sort of, at the central and also on the east Delhi part, we have the higher population density. So these are different thematic map that were created for this analysis, and then these are also plugged with the weight. So weighted score were made in those map. So now in this case, whatever we have observed, that based on the park and ride facility location, so based on this overlap, what we finally find out that these are 10 metro stations where we achieve the maximum weighted score for all the criteria together. So their score, corresponding score compared to the others, and then also the weight. So with that particular weighted score, the maximum score that we obtain for this 10 station among all the metro stations that we have considered. And in this case, Uttam Nagar East, Mundka Industrial Area, Tughlakabad, Dilshad Garden, Rohini West. So these are all stations which are in the periphery. They are found to be effective. Now why? Now whenever you are in close proximity of the urban area, so in that case probably you are not going to use your metro, you can drive alone, okay, you can just drive through. But whenever it is periphery and you want to enter to the urban area, so definitely the distance is more, right, to the CBD where you are going to travel. So for such reason, like, it is very effective that you just make certain smaller amount of your travel, total travel length, by your private vehicles and then get into the public transport. That's why the peripheral area are there. The locations are near hub, near terminal, and then these are different metro lines, so it has distribution. Then also we have certain station like Motinagar, Ajadpur and INA. So they are actually, in the non-peripheral region, and also these are different terminal. So terminal stations are also very important because one may switch from that location to another. So like that we have Shasti Park and all. So here these are all shown. So basically it has a good coverage of peripheral and non-peripheral metro station. Now this is some observation based on the criteria weight and the score assigned to them, and finally the maximum weighted score, we arrange them all the station in that order, and then finally these are the top 10 station which actually can have a higher potential to be treated as a park and ride location, or you can develop it. But definitely depending on the resources, this number can be top 20, top 50, and then also like it requires further research on quantifying that how many parking space are required. So identify 10 transit stations with potential of having this kind of PNR facility that are identified. Uttam Nagar East Metro Station was the most potential location, which is located on the blue line. The locations of potential park and ride were spread in all part to serve the maximum possible area, that periphery and also the non-periphery area. Few located near periphery while other near major activity centers and transit hubs, so that has a proper distribution. Coming to the conclusion, so this is a combination of two distinct technique to precisely identify the potential locations, the GIS and the HP as a MCDM. This also ensured in this study that service to maximum area by introducing a minimum number of PNR locations It is also helpful to development authority for making maximization of the service with minimum utilization of resources. So this is something you can go. So whenever you have more resources, you can go further and you can implement more, looking at the trend, because park and ride in India is not very common. It is just evolving. In recent times only we are focusing on that. So maybe to start with, these are the initial few findings which can be helpful. Now coming to the takeaway from this case study, definitely here we have seen one application of spatial analysis, but at the same time you can also treat it as a mixed method where we have used the GIS and those scoring as a quantitative analysis, and then the criteria weight derived from HP as a qualitative one, and this is the mixed method. But in this context, in this case study context, my intention was to put it as a special method that we have used, where we have used different sort of thematic map using buffer, network analysis, and finally superimposed all of them to come up with that 10 most potential locations in that DMRC network. This is also like a successful demonstration of the use of spatial technique to analyze the information and represent the answers to the problems, that where to locate, which are the locations that we should give the priority. So with that I end here. So already I have summarized the case where we have used the spatial method GIS-MCDM, and where we have used both like some GIS mapping along with the HP, and the combination. These are some further reading. Now with that I end this particular discussion here, and in next lecture we will be discussing very important topic, that is research method for behavioral studies. Nowadays we are much more focusing on that. So we will discuss very basics, because we cannot extend it further, keeping in mind about the course content and all, but this will be an interesting discussion. So thank you for joining. We will be meeting you soon with this particular topic in our next discussion. Thank you.